Hi friends, I hope you all are fine and today we are gonna discuss about the social network analysis and how to work with graph in social network analysis. What is the social network analysis? Social network analysis is a way of investigating social structure through the use of network and graph theory, because we are most toward to graph theory. We used a lot of things for graph theory. So it categorizes network structure in terms of nodes, like uh, uh, nodes for any network. uh, you might have network for Facebook data set. You might have network for other YouTube data set. So there is a link between all these things. So we will go through this. Okay, what we are discussing. So social network analysis is categorizes network structure in terms of nodes, in terms of ties, edges, and links. And how to connect them. The links are, they're called relationship or interactions. There's a lot of example of social network that I will use Facebook combined data set, and we will work with that. So another example of social network analysis is to include social media network, uh, memes spread, and information circulation, like friendship and acquaintance network, business networks, network of networks, knowledge networks, and these are some kind of network, in which we analyze that network, that is by we called social network analysis. Okay, so we are just, this is just the definition, and just for the purpose that you, if you don't know what is the social network analysis, so it is all about that kind of network, social network of social platform to analyze all these things. So what we are going to do, we will use basic libraries called NetworkX, and let me reduce this font. uh, okay, so all right, so what we are going to do, where we are using this network x libraries for plotting these, for working with these graphs. So one thing, if you don't know about the Python, because this code is written in Python. So if you don't know much about this Python thing stuff, so what you can do, I have a 1 hour video lecture of Python, so where you can get through all these things in a simple way. Okay, so let's come to our topic. Okay, so if we want to import our some libraries, so what we do, in last video I and also said that to import any libraries, just you to need to write an import network. Okay, so this is not a big stuff. Okay, so for this, what we are doing, we are here we are just using a Facebook combined data set. So the data set is in form of txt. It is available on internet. You can download that data set and you can work on this. So this is just to help you how to start working with this graphs. So okay, so how to work on a data set to plot as graph and all these things. So this is a matplotlib library. That matplotlib .pyplot is used to plot your graphs. So to plotting this, you'll always use matplotlibs, right? So the next thing is, you have imported this NetworkX as NX. So what you can do, you can just uh, call several function. The function, lot of function is available. So this is a function to read the age list. And you this Facebook command exe, there is some age list, there is notes. So if you want, you have just read a read age list by using this command. So this age list is comes in this G, and if you want to if you want to take the information about this, you just use the info commands. So you are using this info function nx.info, and uh, here is information about this data set. So what this data set is, here number of nodes is 4039, and number of ages is 234, and the average degree is 43.6910. So what are these numbers? So you know about the nodes in graph. Any graph have nodes and edges which connect them. So these two things you simply can understand. And what is this average degree? So I'll tell you this average degree in next slide. So average degree is just how much edges is connected with that node. So that is called degree, and when we combine that things and find the average degree, called average degree. Okay, so uh, um, so what now, we have a basic information about this, and we are here we are drawing this network out of these nodes and these edges and this average degree. All right, so to draw this network, you are having basic info in G, and you are plotting this G by using the nx dot draw network x. So this draw network x method will print these things. So if you print with labels, that what will do, it will here you will see this 1085 857. So these are the labels. So if you write here a false, so this label will not print. And this is the color of node. So these nodes color you can change to green, blue, yellow, and other color. Okay, so this is just things. And if you want to plot number of nodes, number of, because basic information also is a function, is a method which will print all the basic information regarding that. But if you want to plot an individual, like a number of nodes, so what is the number of ages, so here is a command, here is a function called number of nodes function in NetworkX library, and a number of ages function in number of axes. So this will print your those things, how much nodes you have in your data set, and how much ages you have in your data set. Right, now we are talking about the degree distribution using histogram plots. Here we are discussing about the degree distribution. Here we are discussing about the degree distribution using the histogram plot. So what is this degree distribution, and why we use this? So simple definition for this degree distribution is like a degree distribution is the probability distribution of these degrees over the whole network. So these degrees, this degree, every node have some connected edges, and that edges is called the degree. And this finding the probability distribution of this degree over the whole network, we call it as degree distribution. uh, Fine. So for this we are using a collection. So okay, so previously I also discussed about something that I remember, like degree, so that I have told you. And there is one formula for this degree distribution. So that is called if your degree distribution or the degree distribution of a network is defined to be like a fraction of nodes in the network with degree k. So that you can say degree distribution. What I'll repeat again. uh, um, Network of degree distribution of a network is defined to be like fraction of nodes in the network with degree k. Okay, so it means okay, so this is a way of defining this degree distribution, and you are using this import collection, and by using some function. So this is a sorted function which will sort your degrees. So yes, it will sort your degrees, and I have also written that degree sequence. And so what it will do, according to your nodes, like your first node have some degree, your second node have some degree, so according to some order, it will it will uh, it, it will give the degree sequence, like first node have this sequence, second node have this sequence. So according to that sequence, like 1 2 3 5, that order, it will give the degree sequence. And then this collection dot counter will count the degree sequence. So degree count is a variable which contain this degree sequence. Okay, and then there is a zip. So it will uh, combine this all degree counting dot items into these two variables. And so this is a way of plotting, like in previous when we were discussing about the matplotlib, we were discussing about this. So plt is matplot. We imported matplotlib.pyplot as plt. So by using that plt and not subplot, we are giving the access, we are giving what graph we are plotting for this. And these are some title, label, x label, and x take, these things. So these are the basic information of graph. And now what we are doing, we are just we are giving other information, like what should be the size of our axis. And yeah, and there is a some subgraph, and which is out of this x. So g dot subgraph means one more graph we are plotting with this. So two graph in a single things we are doing, so that's why we are using this g dot subgraph at gcc. And we are giving the position also, we are giving a plt dot axis as off. So the layout will be is spring layout. So there is a different layout, you can search for this layout so that you can plot two things in a single graph. And right, so and these are like nx or draw network nodes. So nodes size is like 20. So this is like this much of size. So these are simple things that you can. So now if you print the degree distribution, so so it will print this degree distributions uh, here. So these are the some extra graphs for that. Now once you have a degree distribution, and you can also print the number of triangle out of that. So in an SNA, what is a triangle? So total number of triangle that the network is forming, like connecting three nodes. So how much connection, such connection, triangle connection are there, so it will give that number of triangle. And if you want to print this diameter in social network analysis, so diameter in social network analysis will be 8. So okay, so okay, so what is next? Okay, so next is connected component. So so okay, so if you print how much component is there, total connected component is there. Here you can use this number connected components. So it will give you have one connected component. Because this network is connected, that's why that's why it is completely connected, that's why it is giving the one. And one more thing, if you want to print strongly connected or weakly connected, so remember that is not this command is not for undirected graph. If you have a directed graph, then you can use this strongly connected and a weakly connected um, function. So these two true function is for directed undirected graph. All right, so the next thing is size of connected component. So total size of connected component is 4039, means total of all the nodes, because we have 4039 nodes, right? 4039 nodes. So all 4039 nodes are connected to each other. That's why the graph is called connected graph. And that's why total 4039 connected components are there. Largest connected component is for size of largest connected component is 4039. Now the cluster coefficient is the average clustering, and we are if you want to print a cluster coefficient, so we are using an nx dot average clustering, that is 0.6055 467. So okay, so these are some basic terms, and I'll give you some more uh, things to practice. Like these are basic things, like number of nodes. For number of nodes you can just write an extra number of nodes. For number of A's you can write an extra number of A's, number of isotopes, number of self loops, diameter and triangles, and diameter again, and radius. um, okay, so radius, and we have a center, eccentricity, and periphery. So remember, all these things I will discussed in a separate video. The basic terms, all the basic terms I'll discuss in separate video. What is this connected component, what is this number of connected component, connectivity, age connectivity, all will discuss in the next video. That will be our lecture kind of video, in which I'll give the definitions by using the graph. So what are these and how to calculate all these things, so that I will also that I will also discuss in the new lecture. All right. So this is clustering. So for this, you can just write a length of nx dot clustering, and this is just your clustering. And all right. So these are the basic function that I have gone through, and I thought it might help you to start work with your graphs. So that's why I have made this video. So I think it will help you in some way. So thank you for this watching this video, and I request please subscribe my channel, so I'll put more videos on different topics, like in social network analysis, like machine learning, deep learning, NLP, and with using code. So my focus is more on codes, because students found very difficult to get this kind of code in one place. So that's why I thought I made some videos where I will put what I know, what I have been going through, and useful links also I'll put from where I have taken all these things. So if there, so I will also help in that way also. Okay, so thank you so much for listening me. Please subscribe to my channel so I'll put more videos. Okay, thank you.